Solving a system of equations. That's the main thing we're going to look at today. We're going to start out by reviewing some terminology, then we'll look at solving systems of equations by graphing, substitution, and elimination. Solving systems of equations is the main focus. So a system of equations is a set of systems with the same variables. So if you have two variables, to solve it, you'd need to have two equations. If you had three variables, to solve it, you'd have to have three different equations. A system is considered consistent if the system of equations has one or more solutions, meaning at least one. Typically, it's going to be two intersecting lines. It could be being the same line. We also have inconsistent. That means we have a system that has no solutions, meaning they'd have to be parallel lines. Then we have independent systems, those that have only one answer. So a system is considered consistent and independent if it has one answer. That means one ordered pair, which means it would be two lines that would cross at one point, which means it would be two separate intersecting lines where they cross at one point. A system of equations is considered to be consistent and dependent, meaning they have infinitely many solutions. So in other words, when you graph the two lines, they end up being the same line, one line on top of the others. We also have an inconsistent system which has no solutions. And that would be parallel lines, where your two lines would have the same slope and never meet. Interesting thought on that is parallel lines have so much in common, but they'll never meet. Yes, you're going to get a few puns here and there. So let's take a look at this one here. I'm going to go ahead and graph this first one, and I'm going to make it into y equals mx plus b. So I'm going to subtract an x from both sides. So now I get y by itself. My slope is -1. My y-intercept is 2. So I'll go 2 here. My slope is down 1 over 1, down 1 over 1. And I can continue that pattern. And then I can go ahead and draw in a line. Then I can go ahead and do the same type of thing with my other one. I'll go ahead and get y by itself, so I'll subtract a 2x from both sides. Then get rid of that negative by dividing everything by -1 or multiplying everything by -1, and I get this. My y-intercept is -3. That's what's added or subtracted to the x when y is on one side by itself. My slope is 2, so I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, or it could go down 2 left 1. Either way, I can now go ahead and draw myself a line. Your answer to solve this system is the point where the two lines cross. So to me, it looks like it's about 2/3 and about 1/4 or something. That appears to be about what it is. But solving by graphing sometimes works well. And if the two lines were to cross on a grid mark, that would be your answer. But a lot of times lines are not going to cross on a grid mark. So your answer will be just your best guess based off of what you see from your graph. So graphing is great because it gives you a nice visual about what's going on, but it does not always give you an exact, accurate answer. Now, solving a system by substitution will allow you to get an exact answer. So here's our system. To solve it by substitution works well if one of your variables has a 1 in front of it, which in this case we have a 1 in front of our x, a 1 in front of our y, and actually a -1 in front of this y. Solving by substitution works great if you have any of one of those being a 1. So I'm going to take the top equation, and I'm going to go ahead and get y by itself. So I'm going to subtract x from both sides. Now I get y is equal to an x minus 2. That's what I'm going to plug in for y in the second equation. So I'll go my 2x minus, And then instead of writing y, I'm going to write what I had here of 2 minus x, and then still equal to my 3. Now, a lot of people will forget to distribute this negative sign through, or not put the parentheses through and not distribute the negative sign. So just be aware of that. Distribute through your negative sign, collect your like terms. The 1x onto your 2x gives you 3x. Get x by itself by subtracting or adding 2 to undo your subtracting 2 to both sides. Add 2 to both sides. Then you go ahead and get rid of that timesing by 3 by dividing both sides by 3. Now this is your x. If you want to know what y is, you could go ahead and plug in that 5 over 3 here. You could plug in that 5 over 3 here, and then solve each one of these for y. I think it's easiest to go ahead and plug x into the spot where y is already on one side by itself, because that's what we're trying to get, is y on one side by itself. So if we go ahead and go y equals 2 minus what we just got for x of 5 over 3 there, 2 minus 5 over 3, this is 6 over 3 minus 5 over 3 is 1 over 3. So our x is 5/3, our y is 1/3. So these two lines cross at the point, and any point's an ordered pair. So write your answers as an ordered pair, 5/3, 1/3. And yes, you need to add the parentheses.